Hello everyone and welcome back to Nunley Math. Thank you so much for joining us here today as we continue our discussion of solving quadratic equations. In our previous video, we looked at two methods for solving quadratic equations, both methods relying very heavily on some information we had learned in some previous units. Method number one, we can take a quadratic equation and in some cases we can factor that into its prime factors, and we can use the zero product property to find the missing value. Method number two, we can take the information we learned in our radicals and radical expressions unit, and we can square root both sides of our quadratic equation, and often we can find the solution that way. If you're uncomfortable with those methods, you're going to want to go back and watch those videos before watching this video. This is method number three. We can also solve quadratic equations by completing the square. Completing the square. And I want to talk with you for just a second about what that means. If I were to say to you, what value should go in the box to make this into a trinomial squares pattern? That is not a very complicated process, but only if you remember what a trinomial squares pattern is. So, in my unending generosity, I went back to some previous slideshows and I pulled up the trinomial squares pattern for you. You should remember this from both the exponents and polynomials unit, where we talked about how you could take a binomial times itself and get this pattern. And you should also remember it from our factoring unit, where we discussed if we saw a pattern that fits this side, we could factor it down into its binomials. And so we want to take this trinomial and we want that constant term or that last term to be such that it would create this pattern. Notice what the pattern says. It says the first value in the trinomial needs to be a perfect square. The last value in the trinomial needs to be a perfect square. And the middle term needs to be 2 times the roots of the first and last term. Well, let's take a look. I have a perfect square here. It's x squared. If I look at my middle term, this middle term needs to be 2 times x times some number. So to find that value, I'm going to divide this middle term by 2. 18 divided by 2 is a 9. This middle term is actually 2 times 9 times x. I divide that middle term by 2. That's going to reveal to me what the root of this third term is. And once I know that the root is 9, I just square it and it tells me that this number must be an 81. If I want this to be a trinomial, it has to be x squared plus 18x plus 81. And if I were to factor this, it would be x plus 9 squared. Now I did that very quickly, but remember the important thing is this. This middle term is 2 times the roots. Since this x squared is just x, that means this side has to be 9 squared. Let's do another one. If I give you x squared minus 10x plus something, can you figure out what needs to go in this box? Let me remind you that the middle term has to be the square root of this, well that's the x, and then it has to be times 2 times the square root of this. Well, 10x is 2 times 5 times x. The x squared is over here, the 5 squared is here, so this must be a 25. This is a trinomial square. In fact, if I wanted to factor this, this would be x minus 5 times itself. Got myself a little typo there. We'll go back and fix that after we finish the recording. It would be x minus 5 times itself. Does that make sense? If you're uncomfortable with that, I'm going to recommend you go back and listen to that explanation again and walk through it a couple times. If you feel pretty good with that, I'm going to recommend that you try these over here on the right. I'm going to put them up one at a time. I'm going to recommend that after I put them up, you pause the video, try it on your own, then check to see if yours matches mine. And I would do that for each of these problems. In this example, if I have a 6, this is 2 times 3 times x, which means this number right here needs to be the 3 squared or a 9. In fact, this is x plus 3 times itself, x plus 3, that quantity squared. Did you get that? How about this one? This minus 12b has to be 2 times 6 times b. I need to look at that 6. 6 squared is 36. How about this one? This is 2 times 2 times m, meaning that last value needs to be 2 squared or 4. How about this one? This is 2 times 7 times z. That means the last number is going to be that 7 squared or 49. And the last one, 2 times 10 times b, which means that last number needs to be 10 squared, which is 100. How do you feel about that? Once you do a couple, it shouldn't be too difficult for you. If it still seems very confusing, you're probably going to want to take some time and go back and watch that video again. But I'm hoping that's not too bad for you. How does this help us when we're solving quadratic equations? Well, suppose I ask you to solve this, x squared minus 6x plus 4. Now, when I look at it, the first thing I'm doing is I'm checking to see if this is a trinomial squares pattern already. Because if it is, I could just take this and write it as a binomial squared and use square roots like we did in the previous video. Unfortunately for us, this is not already a trinomial squares. So here's what I'm going to do. I'm going to take that plus 4 right here, and I'm going to subtract it from both sides and get it out of the way for just a minute. All I've done is use the property of equality to rearrange this a little bit. And when I do, you should notice that what's left over here on the left looks a lot like the problems on the previous page. In other words, I would like to take this expression right here and turn it into a trinomial squares pattern, just like you did on the previous page. Notice this number right here, the 6, has to be 2 times 3 times x, which means if I want this to be a trinomial squares pattern, what goes in that last blank must be a plus 9. Now make sure you're clear on that real quick. That's a very important point here. I want to put a number in here that is going to force this to be a trinomial square pattern. And I use the trinomial squares pattern rule to realize that it must be 3 squared or 9. Once you're comfortable with that, let me remind you that you can't just put plus 9s in a problem for no reason. The property of equality says you need to make sure you do it on both sides. So I would like to add a plus 9 here, and I can do that. The property of equality says I can do whatever I want, but I must do it on the other side as well. Put a little star right here. This is the part that causes people the most trouble when they're working on completing the square. They figure this out okay, but they forget that they have to do it on the other side as well. Often that's because they've skipped some steps or tried to do some things in their head. Don't allow yourself to fall into that trap. Make sure you take the time to write it on both sides. Now here's the good news. You've already completed the most difficult part of the problem, because when you simplify that, this left side is going to factor into x minus 3 squared. Remember, the whole point of turning this into a trinomial squares pattern was so that we could factor it into something times itself. The right side I just went ahead and added together. Again, if what I've done there has confused you, you want to pause, watch it again, because that's the most difficult part of what we're doing here today. Once you're at this point, the rest should be very easy because this is what we did in the previous video. We said if I have one side that is a perfect square, to undo that I just square root both sides. Once again, making sure, like in the last video, that we don't forget the plus minus sign. Remember, squares and square roots undo each other, so you're left with x minus 3 equals positive negative radical 5. And just like in the previous video, we add the 3 to both sides, and your answer is 3 plus radical 5. Again, keep in mind you could have put the plus 3 out here and had this as your final answer, but this is not considered to be standard notation. The reason for that is a lot of times people get confused and they can't tell whether the plus 3 is under the radical or not. It's just a good habit to get into to put that plus 3 at the beginning. Not too bad, right? Again, the only tricky part takes place right here when we're completing the square. The whole point of completing the square is to get this to be a trinomial squares pattern that I can factor and then square root. If you feel fairly confident, again, I would try this on my own and then watch the video to see if what I did matched. If you got stuck, of course, you'd start the video from whatever point you get confused. I'm going to assume you've already done that. I'm going to do this one a little bit quicker. I'm going to move that 74 to the other side. Remember, I want this to look like it did in the previous page or in the previous examples, because I would like to take those two terms and add something to them to make them into a trinomial squares pattern. Remember, whatever I do, I have to do on both sides. So, looking over here on the left, how do I make this a trinomial squares pattern? Well, the 18 is 2 times 9 times x, which means what goes in the blank must be an 81. And once I've put that on both sides, I can factor this into x minus 9 squared. X minus 9 squared, I then added my negative 74, my 81 to get the 7, and you've done the hardest part of the problem. From here, we just work on undoing the square by square rooting. Don't forget your plus minus sign. Squares and square roots undo each other. To get rid of the minus 9, we do plus 9, and we put that positive 9 at the beginning, and there's your answer. Not too bad, right? Again, keep in mind, the whole point is to turn this into a trinomial square pattern. One more on this page. Notice this does not match the form that you're used to seeing. Keep in mind that no matter what form the equation is given to you, your goal is to get the quadratic and the linear term on the left together and the constant term over here on the right by itself. So in this case, I'm just going to subtract 16x from both sides. This equation that you're given could be much, much more complex than this. If I ever get one that's really complicated, I just simplify it back to standard form, and then I can treat it like I have all along. Notice the quadratic and linear terms are here. I need to complete the square. What is it that I can put in here that will make this into a trinomial squares pattern? Well, this is 2 times 8 times x, which means this must be 8 squared, or 64. If I put a 64 on one side of the equation, I have to do it on the other side because of the property of equality. That's the most difficult part right there, is figuring out what this number would be. Because once it's a trinomial squares pattern, then I can factor. Once I've factored it, and I've combined my like terms over here on the right, I just square root both sides. Now, this one's kind of fun because 49 is a perfect square. That means it will give us a rational solution. Square root of 49 is 7. Don't forget your plus minus sign. So you've got x minus 8 equals positive or negative 7. I add 8 to both sides, and you get 8 plus or minus radical 7. Keep in mind that we left our answer in this form on the previous examples because we could not take the square root of 5 or the square root of 7 without using irrational numbers. Over here on the right, I can add these together because 7 is a rational number. This is 8 plus 7, and it's also 8 minus 7. This is 15. This is 1. So this has two answers, both 15 and 1. Or you'd say x can be either 15 or x can be a 1. What do you think? Hard or easy? I don't think it's too bad once we get it to trinomial squares pattern. I can take these and make them as long and complex as I want, and they're all basically going to be done the same way. One word of caution to you, though, is you need to make sure that your leading coefficient is a 1 in order to do this. If your leading coefficient is not a 1, this gets much, much harder for you to do. So I'm going to suggest that you make a little note to yourself. I probably should have added it to my slide. Make a little note to yourself off to the side someplace to make sure your leading coefficient is a 1. Scribble that in real fast. Pause the video, take the time to do that. Because if that leading coefficient is not a 1, this is much, much harder for you to do. So here's what I'm going to do. I'm going to take this equation, and I'm going to go back and erase my lines first. I'm going to take this equation, and I'm going to turn this leading coefficient into a 1 by multiplying through the whole thing by a half. Remember, the property of equality says I can do whatever I want as long as I do it on both sides. So I multiply through by a half. Half of 2 becomes 1. Half of 12 becomes 6. Half of 14 becomes 7. Half of 0 stays 0. And now this looks just like all the other examples. At this point, I would pause the video, try and finish this on your own, and then you can skim ahead and see if your answer matches mine. I'm going to do this a little quicker than I've done before. I'm going to move the 7 out of the way because I don't want to deal with that. And then I'm going to ask myself, what can I add that will make this left side into a trinomial squares pattern? Well, 6 is a 3 times 2 times x. 3 squared is 9. And so I'm going to add the 9 to both sides. Since this is a trinomial squares pattern, I'm going to go ahead and factor it. Once I've got it factored, I know that the left side is a perfect square, so I'm going to square root both sides. Don't forget your plus minus sign. Very common spot for an error. Squares and square roots will undo each other. Square root of 16 is a 4. In order to get rid of a plus 3, I subtract 3 from both sides. Your answer is negative 3 plus or minus 4. Remember, since this is a rational number, I have to go back and finish this. I cannot leave this answer in this form. This will have two answers, negative 3 plus 4, which is 1, and negative 3 minus 4, which is negative 7. Here's another one. Again, try this on your own. I'm going to continue doing these more and more quickly because you ought to be getting better and better at them, but you certainly want to make sure you're pausing the video in between and trying it on your own to make sure you're understanding. I'm going to multiply both sides by 1/4. That's going to make sure my leading coefficient is a 1. If this is not a 1, everything is way, way harder. Make sure this is a 1. Once that's a 1, I'm going to move the 18 out of the way. And I'm going to say, what can I add to this left side to make it into a trinomial squares pattern? Well, this is 3 times 2 times 6, or 2 times 3 times 6. That means this needs to be 3 squared, which is a 9. Oh, interesting. That was the same as over here. Did you guys notice that? I just now noticed that. If I'm going to add 9 to the left, I also have to add a 9 to the right. Property of equality says I can do whatever I want, but I got to do it on both sides. I'm then going to factor this left side and then simplify this right side. This is x plus 3 squared equals 27. Square root both sides. Remember, squares and square roots undo each other. Don't forget your plus minus sign. Also keep in mind that 27 is an irrational number, but it is not in simplest radical form. So we want to make sure we change that to simplest radical form as well. This is x plus 3 equals positive or negative 3 radical 3. I put that radical 27 in simplest radical form. To get rid of the plus 3, I need to subtract it from both sides, and I get negative 3 plus or minus 3 radical 3. Now, this is our final answer. Let me put a word of caution in here for you. A lot of my students find themselves making an error right here. because they say, well, negative 3 plus 3 is 0. And they want to call this 0 radical 3, which equals 0. Keep in mind, negative 3 plus 3 is 0, but order of operations says that we have to multiply this together before we add and subtract. Order of operations says multiplication has to take place before the addition and subtraction. And since I can't multiply this together without estimating or rounding this, then I'm going to have to just leave it as it is. Does that make sense? Hopefully that was worthwhile and helpful for you. Keep an eye on that. That's a tricky spot. One last example. Here again, I'm going to ask you to pause the video, try it on your own before you watch me do this. I'm going to clear out my, my leading coefficient by multiplying through by 1/3. Again, I'm going to move that plus 8 to the other side. I'm then going to look for what I can add to the left side to make this into a trinomial squares pattern. Hopefully you realize that's a 16, and then you factor. Make sure you simplify the right side as well. Negative 9 plus 16 is 7. Once it's in this form, you've really done the hardest part. We're going to square root both sides. Don't forget the plus minus sign. Troublesome spot for students. Squares and square roots undo each other. Subtract 4 from both sides. And there's your solution. And that's all we've got for today. Here again, the process I don't think conceptually is very difficult, but there are a lot of spots to forget things if you start skipping steps and are not taking your time. So please, please, please be very conscientious on this. Most of the time, it's not because students don't understand that they missed the problem. Rather, it's because they've done something small or careless along the way. That's all I have for today. Thank you so much for joining us. I really do appreciate it. Make sure if this was useful for you, you give me a big thumbs up. Make sure you ring that bell so that you receive notifications when we publish something new. You guys take care of yourselves, all right? Bye-bye.